Giant solar storm 14,000 years ago leaves the Carrington event in the dust. The Carrington event was a major reality check for rapidly industrializing humanity. In September 1859, the sun unleashed an eruption so powerful it sent electrical current sweeping across Earth's surface, wiping out telegraph systems around the world with fires and mayhem. Around the world, yes. And we've not seen it's like since, but ancient evidence suggests that our sun is capable of even more, so very much more. In the rings of ancient, partially fossilized trees, scientists have found evidence of a solar storm at least an order of magnitude more powerful than the Carrington event. It took place, they say, some 14,300 years ago, well before there was a technology grid to disrupt, and such events more powerful than Carrington appear periodically in the fossil record, but this one is the most powerful ever seen. Solar or geomagnetic storms are common here on Earth. They occur when the sun erupts in a colossal flare or coronal mass ejection, and if the eruption occurs in the direction of the Earth, a huge influx of charged particles will hit our magnetosphere. The effects of this are mostly pretty mild. The interaction between the particles and atmospheric molecules result in some pretty spectacular auroras. It can disrupt satellite and radio communications at certain bands. During particularly powerful and thankfully relatively rare solar storms, the disruption to Earth's electromagnetic field can produce currents that can impact power grids. Another quirk of solar storms is the effect that they have on radioactive carbon-14 constantly raining down on Earth. This radiocarbon is produced in the upper atmosphere as cosmic particles interact with the atmospheric particles. Carbon-14 is incorporated into organisms such as trees and animals, and because it decays at a known rate, scientists can use it to determine when these organisms lived. It can also reveal historic solar eruptions hidden in the annual rings of old trees. Radiocarbon is constantly being produced in the upper atmosphere through a chain of reactions initiated by cosmic rays, explains geologist Edward Bard of the Collège de France and European Centre for Research and Teaching Environmental Geosciences, CREGE. Recently, scientists have found that extreme solar events, including solar flares and coronal mass ejections, can also create short-term bursts of energetic particles, which are preserved as huge spikes in radiocarbon production occurring over the course of just a single year. The solar storm that took place 14,300 years ago was found in subfossilized trees within the eroded banks of the Druzette River in the southern French Alps. The subfossil is one that has not yet completed the fossilization process. The researchers created slices of these trees and found a ring with a huge spike in radiocarbon dated around 14,300 years ago. We have other records of this time. The ice cores extracted from Greenland at around 14,300 years ago mark. The researchers found in these ice cores a higher concentration of an isotope of beryllium that is also linked to a radiation storm. The concentrations of both of these signatures are consistent with what we call Miyake events. These are incredibly powerful geomagnetic storms, way more powerful than the Carrington event. Included in this new discovery, 9 Miyake events have been identified in the last 15,000 years, the most recent being about the year 774 AD. We are not entirely sure what causes them. Solar storms are thought to be the most likely, but nearby supernova could also be responsible. Either way, the effects would probably be the same here on Earth, devastating. Extreme solar storms could have huge impacts on Earth. Such superstorms could permanently damage the transformers in our electricity grids, resulting in huge and widespread blackouts lasting for months, says statistician Tim Heaton of the University of Leeds in the UK. A precise understanding of our past is essential if we want to accurately predict our future and mitigate potential risks, we still have much to learn. Each new discovery not only helps answer existing key questions, but can also generate new ones. The research was published in the Philosophical Transactions of the Royal Society A, and this is on Science Alert by Michelle Starr. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.